Hi, kids. I want to go over the directions for the second activity on your moon phases playlist. I want to show you your moon phases playlist so that you can see it. You'll do this one, and then there's another video attached to the other playlist. So here's your playlist, and you're going to see that the extensions for us, for our gifted friends, are here in blue. This first one, which I will link everything in here, is the Apollo 12 landing area on the moon. And the connection with this activity is really with scaling. I know that you're doing scale factors and talking about scaling in Mr. Leslie and Mr. Rooney's math class. So I thought it'd be kind of like a great time for us to connect that. So you're going to get this packet. It looks like this. You'll get that in your gifted folder. I'm going to go through the directions, and I'm going to give you a couple of tips today, because I do think that some of it, if you kind of don't have a background knowledge, plus I'm sure I'm going to get a couple of questions. So I figured I would try to answer as many questions as I can right now so that you can go ahead with this activity. There's not one black or white answer because it really depends on your measurement. So I'm going to tell you, also going to need this millimeter ruler, and there's a bunch in that folder, so share them. Okay, so there should be enough in there for everyone to share per class. When you're done, put it back nicely. Don't crinkle it, okay, because then it won't work for the next person. So what you're going to do is, you'll notice, I'm going to just read this. So this is NASA's lunar orbiter from the lunar orbit, and it's about 21 kilometers or 13 miles, captured the sharpest images ever taken from space of the Apollo 12 landing. So here's what the worksheet looks like. And all of this information here. So here is the picture of, which is a little blurry. So I'm going to point out where everything is. All right. And so these images are taken from space, and they're the twists and turns of the paths made when the astronauts explored the lunar surface. One of the details that shows up is the bright L shape in the Apollo 12 image. This marks the locations of cables running from the Apollo Lunar Surface Experiments package. We're going to call it LSAP. That's how you'll notice it referred to in this packet. Central Station, to two of its instruments. So although the cables are much smaller for direct viewing, they show up because they reflect light very well. That's how these pictures. So I'm going to tell you what each of these is, because you're going to need to know. And it's really hard to see because I'm in like a really dark space. I probably need my flashlight on. So this is the LSAP equipment that we're talking about. That's right here. This is LSAP. And you're going to need to know this one. This one is the descent crescent stage right here. See it right here? There's a little arrow. This one is right here called the Surveyor Crater. You need to know this. And then this is the Surveyor, let me look at it here. I can't really see it. This is the spacecraft right here. Okay, so you're going to need to know 1, 2, 3, 4, these. And then you're going to need to know this one over here, which is the sharp crater over here in the corner. All right. So the first problem is, following one of the walking paths, about how many meters did the astronauts have to walk from A, the LSAP, which is this thing, LSEP, all right here, to the descent stage. And here's the descent stage. So you need to know this measurement right here. And then they give you these specific directions. They want you to go around the Surveyor Crater and finally to the Surveyor spacecraft. So what you have to do is, you have to take this path here. You have to make sure you go around this crater, all right? And then here it is over here. So here, around this crater, and then over to this spacecraft, okay? So that's the measurement you almost need to go boom, 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 right? You got to measure that, add it up, okay? The first tip I want to give you is, it's in the worksheet. I'm going to add it here. I didn't put it in yet. But the other bit of information that you're going to need to know is the fact that the image scale is about 100 meters. And when you do this, they wanted you to do this, but I didn't feel like you had time to do it. So the other information that you're going to need to know is, hold on, where did I put it? Here it is. The answer, so if you took a typical laser printer, right, and you measured a 100-meter bar with a millimeter ruler, you're going to get about 23 millimeters, yields an image scale of about 100 meters divided by the 23 millimeters is going to give you 4.3 meters. So you need the 4.3 meters information in order to solve A and B. I'll put that in this problem so you have that necessary information. So right here is for A, you're going to label it A. You're going to need the 4.3 meters measurement with the distance that you calculate around A, okay? And then for B, you're going to track the segments, again, doing the same scale factor, okay, but going to sharp crater. So you're going to do the same thing, but mathematically, but you're going to go from here down to here, all right, here to figure out that calculation for A and B, all right? For problem number 2, I think it's pretty straightforward. I don't think I need to give you too much. What I will tell you is it says using your favorite method. I'm going to give you a hint, all right? They want to know how many craters, right? They want to know how many craters you can see across the whole area. You're not going to count every single crater. That's silly. There's a method to figuring it out using scaling, all right? Lots of people, artists that actually do those huge murals in Philadelphia, like on the buildings, they use this method. All right. So I'm going to give you a little hint. What you can do is you should grid this whole area. Grid it, okay? And you can determine how you want to grid that. So if you determine I'm going to grid it 4x4, 4x5, you decide, okay, whatever that is. Once you grid this picture, and you can write right on this packet, then what you do is you only count one square out of the whole entire grid to then mathematically figure out about an estimate on how many craters that would be for the whole picture. Okay, so that's my little hint to you. I would grid this, all right? And you determine how you're going to grid it, and then mathematically how you figure out the area, the craters for the whole entire area. The last question here, okay, it says if the craters were created over a period of 3 billion years, about how many have been the average time between impacts to form the craters you see? So this one, my little hint to you is you have to look for rate. All right, so you've done unit rates before. So you almost need to see, take an estimate, trial and error, how X amount of craters, right, over an average. And then you're going to give me an estimate, okay? So you have to say X amount of craters, you determine what X is, and then give me an estimate of how much you would see, all right, over that period of time. So you're looking for the average time between impacts of craters. So you're going to have to do a little variable there, all right? So if you have any other questions, you can certainly come see me. You can ask your teachers. They might be able to help you. I think you could take it to your math teachers. They might be able to help you mathematically. It's only 3 short questions, so I think you'll be fine. Then just remember that you're going to go ahead and do this moon phase percentages that we talked about, right? This calculate, doing these equations. And then if you're done early, you didn't need a lot of time, then what you can do is you can work on these task cards, which is this you have to do. This is everybody in class is doing it, right? All of your friends are doing that as well. And then all of your friends are doing these moon phase task cards. So you can, obviously you have to do these 2 in blue. You have to do this one as well. And then this one, maybe I'll color this one. You should work on this if you are done everything else. I don't want you to sit there and waste time, but you don't have to do every single one. Your other friends who are not in our gifted program, they have to do every single one. You do as many as you can. I don't want you to sit idly and do nothing, all right? I don't know how long this activity will take you. I think for some it might be really quick, and for some you might need a little bit more time to think about those math problems, okay? So enjoy the project. Remember, I am here. Message me. Don't just ask your friends, all right? They might not know the answers. You can message me or you can come visit me. All right, and we can schedule something to sit here and talk. All right, have a good time with this, and I can't wait to see what you produce. Bye now.